Hello everybody, this is Mrs. Snook with a review of radicals. The first thing we're going to do is simplify radicals, and then we're going to do some operations with radicals, adding, subtracting, multiplying, and dividing. So the first thing for simplifying radicals, that would be if you were trying to do something like find the square root of 50. And I'm going to show you two ways to do this. The first way is to find the largest perfect square that is a factor, and then the other way is using factor trees. So for the first way, it's really helpful to know your perfect squares for the integers 1 through 16. So I'm going to go ahead and fill those in. I'm going to pause for a moment while I fill those in and try filling in yours and seeing if yours match mine. All right, so I've filled in my chart with all of my perfect squares. And the first example we're going to do is we're going to find the square root of 50. So look in the chart and find a perfect square. It's the largest perfect square that is also a factor of 50. And in this case, that would be 25. And so then we're going to write the factors with the perfect square first. So 25 and 2, because 25 times 2 makes 50. So then when I square root 50, what I'm going to do is I'm going to square root the first one. So square root your perfect square factor. And that gives me 5. And then the other factor is stuck under the radical. So then I get a square root of 2. So I'm going to do a couple examples this way. Number one, 24. The largest perfect square is 4, and then the other factor is 6. So when I do the square root of 24, I'm going to square root 4, which is 2, and then 6 is stuck under the radical. Let's do 32. That one is 16 and 2. So when I square root 32, I'm going to square root the 16. That gives me 4. The 2 is stuck under the radical, so I get 4 times the square root of 2. Do one more like this. We'll do the square root of 75. The perfect square for that is 25, and then times 3, you get 75. Square root the 25, you get 5, and then square root of 3 is stuck under the radical, so you have 5 square root of 3. Now the second way that you can do this is using factor trees. And I am perfectly fine with you choosing either method. So for factor trees, let's do the square root of 98. I'm going to think of the first two factors that happen to come into my head. 98 is even, so I'm going to do 2, and then when I divide 98 by 4, I get 49. And then I can keep dividing. 49 is 7 times 7. So I have a pair of 7s, so 49 is 7 squared. And then the 2 is the other factor. So when I square root that, because I have a pair of 7s, I just pull one of those out of the square root, so I'm going to get 7, and the 2 is stuck under the radical. Let's do that again. Let's do 450. First two factors that come to my mind are 45 and 10. 45 I know splits into 9 times 5. 10 is 5 times 2. Now I happen to recognize 9 as a perfect square. That's 3 squared. So that's the 9. I have 2 5s, so I get a 5 squared, and the 2 is stuck under the radical. So now when I do the square root of 450, I'm going to square root the 3, so I get a 3. Square root the 5 squared, I get a 5. And then the 2 is stuck under the radical, so then this becomes 15 square root of 2. All right, so now the next operations are going to be adding and subtracting radicals. So if you recall back from Algebra 1, we can combine like terms. So if I had 2x plus 5x, both of them have an x, so that's your like term. So I put x there, And then all I have to do is add their coefficients. 2 plus 5 makes 7, so I have 7x. I can do the same thing when adding radicals. This time, instead of x, the square root of 2 is the like term. So I'm going to put square root of 2, that's my like term. 2 plus 5 is 7, so I get 7 square root of 2. Just add those coefficients together. Next one, careful on this one, we have square root of 12 plus the square root of 27. These radicals are not the same. So what I'm going to do first is I'm going to simplify these radicals and then look to see if I have like terms. So when I simplify the square root of 12, that's a 4 times a 3. 4 is a perfect square, so I square root that. 3 is stuck under the radical. Do the same thing with 27. That becomes a 9 times 3. 9 is a perfect square, so square root that, I get 3. And then the other 3 is stuck under the radical. So when I add these two together, I'm actually going to get 2 square root of 3 plus 3 square root of 3. Now I have like terms. Add the coefficients, I get 5 times the square root of 3. Now subtracting works very much the same way. Instead of adding my coefficients, I will subtract the coefficients. So now let's take a look at 5 square root of 32 minus 2 square root of 6. Simplify first, so I'm going to simplify that 32. I get a 16 times a 2. 16 is a perfect square, so I'm going to square root that. So I have 5 times, square root of 16 is 4, and the 2 is stuck under the radical, minus 2 square root of 6. 5 times 4 is 20, square root of 2, minus 2 square root of 6. This does not simplify any further. Now the next thing we're going to do is multiply and divide radicals. And the general rule is inside by inside times outside by outside. So if you look at our first example, we have square root of 3 times square root of 2. On the outside, they both have an invisible 1, whereas on the inside, we have a square root of 2 and a square root of 3. So that's going to be square root of 6. Now take a look at example 2. We have 4 times the square root of 3 times 2 times the square root of 6. So 4 times 2, that's going to be 8. And then we have a square root of 3 times the square root of 6 is square root of 18. Now let's simplify square root of 18. That's 9 times 2. So therefore 9, square root that, I get 3. So I'm going to have 8 times 3 square root of 2. And then 8 times 3 is 24. Square root of 2 is our final answer. Next one we're going to do is dividing. We're going to do the square root of 108 over 2 square root of 3. We're going to have the square root of 108. We're going to divide this by 2 times the square root of 3. So the first thing I'm going to do is simplify the radical in the numerator. So again, simplify first. So when I'm simplifying 108, first things that come to my mind is 54 times 2. 54 is 6 times 9. That 9, that's a 3 times a 3. So I'm going to get a 3 squared. I then, for the 6, I have a 2 times a 3. So I have another 2 squared. And then stuck under the radical is that 3. And then in our denominator, it is still 2 square root of 3. So now take a look. When I square root my 3 squared and square root my 2 squared, what happens is The 3 comes out from the 3 squared. The 2 comes out from the 2 squared. The square root of 3 stays under the radical. We were dividing all that by 2 square root of 3. Those cancel, those cancel. So 3 is the final answer for this one. Okay, now what happens if when you do your dividing, you end up with a square root in the denominator? This is called rationalize. So rationalizing the denominator. So our first one is 4 square root of 4 divided by the square root of 6. Now when you have a radical in the denominator, what you're going to do is you're going to multiply that fraction, the numerator and the denominator, by a very special form of 1. And what I'm choosing to do is I take whatever is in the denominator, in this case square root of 6, and I'm going to put that in both the numerator and the denominator of my fraction. And then when I multiply, I'm allowed to multiply underneath the radicals, so I will get a 4 square root of 24, and that's going to be 4 times the square root of 6 times 6. Okay, or 36. So recall that you can multiply under a radical, so you can just go straight here to 36, and our 4 isn't there. Okay. Now the square root of 36, well, 36 is a perfect square, so I'm going to get 4 square root of 24 over 6. So now I've got 2 square root of 24 over 3. Now check this out. We can even go further. Do you see that 6 times 4 is 24? So I can pull another square root out of that radical. So I'm going to do a 2. I'm going to pull that 2 out, so 2 square root of 6 over 3. So our final answer is 4 square root of 6 over 3. Let's take a look at another one. I've got square root of 16 over square root of 12. Go ahead and rationalize. And that gives me, in my numerator, I'm going to have square root of 16 times 12. That's 192. And then square root of 12 times square root of 12, that's going to be the square root of 144, which is a perfect square. That brings us right back to 12. So now all I have to do is simplify the square root of 192. I notice that's even, so the first thing I think of doing is pulling out a 2. So I'm going to divide 192 by 2, and I got 96. I'm going to divide by 2, and I get 48. 48 I know is 16 times 3. So here's a pair of 2s, so I get a 2 squared. 16 is 4 squared times 3. So what I can do is I can pull out a 2 and pull out a 4, and that 3 is going to be stuck under the radical. So I pull out a 2, pull out a 4, square root of 3 is stuck under the radical, and I've got a 12. Well, check it out. 12 cancels with 4. That gives me a 3. So now my answer is 2 square root of 3 over 3. All right, that's it for today's video. Thank you for watching and have a great day.